Preteen, welcome to Module 1, Topic 3. So odd I can't even. Let's go ahead and dive into power functions. Okay, so the idea behind this warm-up, I just want to review the key skills standard 4.2 it's on and every single test is your ability to precisely evaluate. We're going to have two inputs. We're going to have it when x is equal to 2. And then we're going to have it when x is equal to -3. And I just want to demonstrate number 1 and number 2. So in number 1, when I substitute 2 in, 2 to the 4th power means 2 times 2 times 2 times 2. When I evaluate it, I like to go ahead and do it in parts. I'm going to do this, and they're being multiplied together. Likewise, with -3, though, I make sure to contain good form. I contain my negative in parentheses, contain the negativity. I'm going to go ahead and put it to the 4th power, and this is going to be 4 -3s. Remember, parentheses next to each other implies multiplication. I'm going to do this in the same method. I'm going to multiply a negative times a negative is a positive 9. Times -3 times -3. 9 times -3 is going to be -27 times -3, which is going to be a positive 81. Notice how 2 negatives made a positive, 3 negatives made a negative, but the 4th made it positive again. I'm just previewing for the future. In number 2, same idea. Can you substitute it in correctly? So it's going to be -2 squared plus 1. It's important when evaluating it that you apply the exponent first. So it's going to be -4 plus 1, which is -3. However, if I were substituting in -3 squared plus 1, I would have to evaluate the exponent first. -3 times itself is going to be positive 9. Now, this step is optional writing down, but I just want to display that the output of -3 squared is positive 9, and now it's going to become -9 plus 1, making it into something I can evaluate. Notice how the grouping symbol affects some of these. In number 3, if I were to do this again, I'm going to substitute negative what? -2 squared minus 1. -2 times -2 is going to be a positive 4 minus 1, which is going to be 3. Likewise, I'm going to go ahead and put my -3 squared minus 1. A -3 turns into positive 3 squared minus 1. 3 squared is 9 minus 1, which is 8. You can go ahead and do number 4 by itself. Take a moment, pause, read these learning goals. Here are the key terms of the function. Okay, our guiding question is, you have analyzed and built quadratic and cubic functions of lesser degree. What are the characteristics of the graphs of power functions? So, we've studied linear functions, quadratic functions, and now we will explore more polynomial functions. A common type of polynomial function, which you have also studied, is a power function. A power function is the form of px is equal to ax to the n. So this is just the generic formula. And what this is meaning is a power function can be like 2x squared, 3x to the third, while a exponential will look like 2 to the x, 3 to the x. Also, just to review, remember the degree can tell you about the graph. If the degree is 1, it's linear, aka in the first graph. Degree 2, quadratic. Degree 3, it's a cubic. And when it's greater than 3, when the degree is greater than 3, it's going to be a polynomial. So consider each power function in its graph in the sequence shown below. So notice these graphs. Well, I know it goes linear, I know it goes quadratic, and then cubic. X to the 4th looks kind of to be like a quadratic. But it's got like a more flat bottom. It almost more looks like a U. Well, then look at this guy. This looks very similar. Notice how both this graph and this graph, the end behavior looks to be the same. This pattern seems to be alternating. So, sketch and label the next two graphs in the sequence. Well, it left off at x to the 7th and then x to the 8th. Okay, x to the 7th. Notice how it's alternating. It's going from, let's look at the power. Here it's a 3, here it's a 5, here it's a 2, 4, 6, 7 is odd. So it's going to be like the red graph. This is 8, so it's going to be even. Voila! I don't even have any information, but I can make these sketches. So we have to basically talk what we know about the graphs in the sequence. And I'm going to basically give you a couple of points. The summary is that odd powered functions have opposite end behaviors. Even powered functions have the same end behavior. And then as the exponent grows larger, the center of the graph gets flatter. The idea here is odd powered functions have opposite end behaviors. Notice how the graph is pointing in opposite sides because it's an odd. Even have the same end behavior. Let's go ahead and jump up. All even graphs notice how the odds have opposite end behaviors. Even x to the 1st, this is an odd, and has opposite end behaviors. And then they all get flatter in the center as the exponent gets bigger. So if you want to think about it, well, Mr. Z, what about the opposite case? Can I have a graph that looks like so? And looks like so? And the answer is yeah. This is just a transformation. This is just the negative version of the power function. Remember when you multiply by a -1, it results in a reflection over the x-axis? Okay, that's it for now.